Hey everyone, let's jump right into this explainer for Learning Source-Based Model Video Overview. If you're tracking along, the exact lesson ID we're covering today is STEM AI Unit 03, Lesson Pack 01, Learning Source-Based Model Video Overview, which fits right into Grade 7 Introduction to AI, Unit 03, Lesson 1. Today, we're going to pull back the curtain on how machines actually learn and, maybe more importantly, how we make sure they do it safely. Let's get to it. So we've got to start by busting a massive misconception. When most people hear the term artificial intelligence, they immediately picture a computer just mindlessly following a giant, super long list of direct rules written out by human programmers. They kind of think an AI just checks that list to figure out what to do next. But honestly, in modern AI, that is not exactly how it works. To clear this up, it really helps to look at how the OECD, the Organization for Economic Cooperation and Development, breaks it down. They explain that older symbolic AI did actually use those human logical rules. A programmer literally sat there and typed out all the constraints, but modern statistical AI, what we usually just call machine learning, is a whole different ballgame. Instead of following a strict human rulebook, the machine deduces trends and conclusions from a huge set of patterns. Right, so here is the crucial point. Machine learning models rely on data to train and evaluate themselves. Like the OECD explains, these systems literally teach themselves over time. They figure things out through patterns, inferences, and a whole lot of trial and error, rather than just sitting around waiting for a human to write out the code line by line. And that brings us to what a source-based model actually is. When an AI system takes in raw data from its environment, it builds its own internal logic to make sense of it. It builds a statistical model based entirely on the source data it was fed. So it isn't explicitly programmed with rigid rules. Instead, it basically builds its own mathematical map of patterns to make decisions. Now, you might be wondering, this brings up a really interesting and kind of scary risk. If an AI is out there teaching itself over time using trial and error, and human programmers aren't writing out the specific rules, how in the world do we make sure the model it builds is actually safe and accurate? What if it learns the entirely wrong thing? Well, to tackle this very real challenge, developers use something called the NIST AI Risk Management Framework, or AIRMF. Created by the National Institute of Standards and Technology, this is a totally voluntary system designed specifically to bake trustworthiness right into AI systems. It all runs on 4 core functions: govern, map, measure, and manage. Because the AI is constantly learning from statistical patterns instead of static rules, humans absolutely have to step in using those NIST functions. We use this framework to continuously check the design, the development, and the deployment of the AI. We have to make sure the learned model isn't making dangerous, biased, or just plain incorrect mistakes. With machine learning, you definitely can't just set it and forget it.
All right, let's look at a worked example, the school recycling AI.
Let's imagine your school wants to build a simple AI to automatically sort recycling into paper and plastic bins. How would it learn? Remember, we aren't giving it a strict rule like, if it's clear and crinkly, it's plastic. Instead, we feed it data. We show it thousands of photos of paper and thousands of photos of plastic. The AI finds the visual patterns all on its own and builds a statistical model to deduce where the trash belongs. But hold on a second. Before we attach this AI to the actual school trash cans, how do we know it actually works? What if it picked up on the wrong pattern entirely and decides to just chuck all the plastic bottles into the paper bin? This brilliantly illustrates one of those core functions from the NIST framework, the measure function. Before the AI ever goes live, we have to measure its performance. We test the AI's learned model against brand new pieces of trash it has literally never seen before, just to evaluate its trustworthiness. If the measurements check out, then we can trust the model. Okay, section, your turn, the cafeteria AI. Now it's your turn to transfer this to a totally new scenario. Imagine a new AI model predicting school lunch demand. It looks at past cafeteria data, what students ordered, the weather, the day of the week, and finds patterns to predict exactly how much pizza the school should order for this coming Friday. But let's identify a risk here. What if the AI model gets it wrong? What if the statistical trend was slightly off and it predicts way too little pizza and kids go hungry? Which part of the NIST framework helps us deal with a risk once it's already been identified? The answer is the NIST manage function. While measure is all about testing, manage means the school actually takes action to mitigate the risk. In this case, the school might manage the risk by keeping a secret stash of frozen backup pizzas in the freezer, just in case the AI's pattern finding made a mistake. So, to wrap this all up, here are the absolutely crucial takeaways. Modern machine learning doesn't follow strict, human-written rules. It learns trends from data to build its own source-based model. And because AI systems teach themselves over time, we rely on human-guided tools like the NIST AI Risk Management Framework to ensure those models stay safe, accurate, and trustworthy. And that completely wraps up our explainer for this lesson, officially titled Learning Source-Based Model Video Overview under the exact lesson ID STEM SIS-AI-UNIT-03-lesson-pack-01-learning-source-based model-video overview. I'll leave you with this one final thought. As you walk the halls of your school today, just look around. What other hidden patterns could a machine learning system learn from your environment? And if you were the one building it, how would you step in to govern, map, measure, and manage the risks? Keep asking questions, guys, and keep learning. Catch you next time.